Hi, welcome. This is the final project presentation for Interactive Data Science class at Carnegie Mellon University. I am Sachin, and together with Samarth and Kevin, we will present our project. Our project is based on the urban study on bike share across San Francisco. The population of the world is set to grow from 7 billion today to 9.2 billion by 2050, and this presents intimidating challenges in the range of diverse spheres, from transportation to climate change. But as this growth is accompanied by exodus from the countryside to cities in the past, we can already know that there are a few issues set to become more thorny than the provision of urban transport. Indeed, the proportion of the global population living in the cities is expected to rise from 50% in 2010 to 70% in 2050. And yet, while the urban mobility currently accounts for 64% of the overall mobility, it is expected to almost triple between now and 2050, with the result that the average time a citizen will spend trapped in the traffic condition could also triple to 106 hours a year. The problem is, in fact, that the city workers are responsible for creating a disproportionate amount of global GDP. By 2025, their contribution is expected to a total of 86%. In such a context, it is vital that the urban residents are in a position to move around freely. We can endlessly optimize the road network by widening streets, adding ramps, squeezing the roundabouts, or flat out burying the problems with the loads of tunnels, but the resources are shortening day by day. Often a more elegant solution is to reduce the amount of traffic that takes to the roads in the first place. There's lots of ways to reduce demand so that the people and the things move efficiently around the city. With the goal of promoting cycling as a sustainable urban transportation, which is available to everyone, city cycling emphasizes that bicycling should not be limited to those who are highly trained, extremely fit, but as a sustainable mode of transportation to decongest the roads. Bike sharing can also be a powerful way to improve the mobility options of socially disadvantaged communities who struggle to afford car ownership and do not have the reliable subway access. Bike sharing systems are a means of renting bicycles, where the process of obtaining membership, rental, and bike return is automated via a network of kiosk locations throughout the city. Using these systems, people are able to rent a bike from one location and return it to a different place on the need basis. The biggest problem with bike share system is that the repair and the maintenance of these stations is a very costly business. Due to this, most of the time the service stations end up not using to the potential. One of the biggest inefficiencies of the city biking system is either not being able to meet the growing demand or not utilizing the stations to their full potential. This demand is hefty variable, and it is almost impossible to know what will be the demand on a particular day. Cycling is still not the most popular mode of transport, but the increase in station already suggests that the change of mode of transport in the mindset of people. One of the cities in the US with the highest bike infrastructure is San Francisco, which has a growing bike share program for residents and tourists alike. As of 2019, the city of the Bay counted over 10.8 million bikes and added 670 bike racks according to SFMDA data. So our research question is, how can we improve the existing bike ride system efficiently in San Francisco to decongest the city? The goal of our project is to analyze the hidden layers of data among the daily travel of cyclists in the city of San Francisco. In order to do so, the various relationships are identified and necessary EDA has been performed to understand how cyclists travel in the city. We are looking to compare how users are interacting with the bike sharing system. We are also interested in figuring out the insights that are of interest to the bike share managers, such as which stations have a large or small amount of bikes at a given date, time, and weather. Essentially, one of the goals of the project will be to use machine learning models to help allocate the correct amount of bikes for each station. In order to do this, we are interested in looking at a few key relationships, such as the location, hour, month, weather, weekdays, weekends, distance, and more. The hundreds of station location in San Francisco are able to tell us about this relationship and help us identify how to make this choice better. It is also important to understand what time of the day these centers are most active. The data generated by these systems makes them attractive because of the duration of the travel, departure location, arrival location and the time elapsed is recorded and cannot be otherwise quantified, as the movements are not predefined and are based on users. Bike sharing systems therefore function as a sensor network, which can be used for studying mobility in a city. Apart from interesting real-world applications of bike sharing systems, the characteristics of data being generated by these systems make them attractive for the research. Opposed to the other transport services such as bus and subway, the duration of the travel, departure, and the arrival position is exactly recorded in these systems. This feature turns out the bike sharing system into a virtual sensor network that can be used for sensing mobility in the city. Hence, it is expected that the most of the important events in the city could be detected via the monitoring of these data.
All right, so now we're going to do a quick demo of the interactive application that we built for this project. Like Sachin mentioned, we're going to be looking at demand for the different stations, the bike share stations in the San Francisco Bay Area. The data set that we used is from the SF Bay Area Bike Share from August 2013 to 2015. And it's meant to provide people in the Bay Area an easy way to travel. It came from a Kaggle link, and it provided us with a SQL database, which we converted to a series of CSV files that had trips, stations, weather, and a bunch of other things. The data set is part of the SF's Open Data Project, and bike share data from 2013 to the present is also available. And we focus on the beginning of the program to note the program adoption. So a little bit more background on the data. In 2013, the SF Municipal Transportation Agency partnered with various agencies across the entire Bay Area. Bike shares were designed to provide an equitable and sustainable form of public transportation available in subscription or per ride payment, which is noted as customer. The aim was to allow people to make short trips by bike to avoid the notorious Bay Area traffic and to provide options for commuters and different tourists. So let's take a quick look at the first interactive element that we built. Essentially, we're interested in looking at the demand for the different stations based on a multitude of different variables that was provided to us. Most of the trips you can see here happen in the San Francisco area, but since this is the SF Bay Area bike share, there's also trips that happened around Palo Alto and Mountain View, and then also a good chunk of trips that happened around San Jose. So the different variables that we're looking at tweaking to see how the bike share trips and the duration and the trips per station and which stations are more popular are the hour range. You can also look at where trips are starting from or where trips are ending. You can also look at the subscription type. So if you wanted to see, for example, trips that subscribers are doing, so these are probably people that are using the bikes for their daily commute, or customers, which are probably people that are tourists. You can see that. You can also select the months and the days of the week. So if you want to see how the difference between weekends or weekdays or summer months or when the weather is a little colder. So I'll just walk through like a quick example. Right now we're looking at between 6 a.m. and 10 a.m. So we can see here for when stations are starting, and we're looking at all of them for around the summer months and Monday, Tuesday, Wednesday. We can see these are where most of the trips are happening. The average trip duration is 11 minutes. And on average for each station, it's around 7 trips are happening. We can also see the most popular stations here. So these are the most popular stations, the trips that are happening within this time range. And these are the least popular stations. So we have information on like where trips are which stations are not being used in this time range as well. So for example, let's do a query here. So let's look at maybe like on weekends, and let's keep it for the summer months. Maybe let's look at where trips are ending, and then for only like customers. So these are probably like tourists. It's gonna take a little bit to run because we're crunching through 600,000 rows. And yeah, so essentially we have some information. So displaying trips for, we have 73 days worth of data. Average trip duration is now 42 minutes. And this is where most of the trips are happening. Ending, I guess. So people are going from all across San Francisco to these 2 locations. And we can also see how that works for Palo Alto and San Jose. So now I'll leave it off to Kevin to explain the machine learning model that we built for predicting bike station demand.
Yeah, thanks, Samarth and Sachin. So here is where our machine learning comes in. So we're sort of defining usage in this part of the sort of web page. We're essentially calling usage or demand to be the number of rides originating at a particular station. So the idea is that we predict this usage, and then we're able to see which stations aren't really being utilized to their full potential, which stations might not be able to meet their demand, and what kind of factors might be an indicator of what demand might be. So here you can see you can select different start stations, but right now we're looking at all those different stations. So no need to click any of them. This is just right now we have 1 year, across 1 year. You can see sort of that there's a lot of usage in the summer months, but in general, the main trend is just that there's going to be a lot less usage on weekends than on weekdays. But you can also see some tapering off in sort of December as the winter months start to come and more rain and more cold starts to happen in SF. So if you scroll down a little bit, we have the error for our model. So we trained a regression model, and there's a small model comparison section at the bottom there. But you can see that, you know, our model's doing pretty well. We have most error around 0. We have some outliers, possibly due to all sorts of things like, you know, events maybe happening around SF, or, you know, special holidays might be changing the amount of usage that we get in each station. Scroll down just a little bit more, and then we have the model comparison. So we just basically test all these different models, and we try to see which one does the best. The one that turns out to be the best is an ensembling method that uses gradient boosting. So our last visualization at the bottom there is sort of the average test point versus average prediction. So across a year, basically for each day, how well are we doing across all the stations? You can see that our graph does adhere pretty closely to the actual graph. And this is, of course, this is test data. So the model has never seen this sort of data before. So this is really quantifying how well our model generalizes, or not quantifying, but visualizing. But you know, about our whole project, there are some limitations and considerations. First of all, you'll note that our time frame is from September 2013 to somewhere in 2015, and SF has evolved their program since then, but there are still places in the country and in the world that adopt a similar system to this sort of system that San Francisco itself has phased out. But yeah, this is data collected from a pilot program. There's a lot of benefits to studying it because adopting bike share programs is always the hurdle that everyone has to overcome for a sustainable mode of travel. But yeah, SF has changed their bike share system. They outsourced some work to Lyft. They have electric bikes. They have bikes left all around the city instead of only at particular stations. They've rebranded it. There's all sorts of optimizations they've done to make the system sort of more friendly. And all of the same like sort of revolutions in technology that you see in sort of across the industry of you know, ride sharing and bike sharing and, you know, that type of thing. But yeah, we really believe that analyzing this bike data can bring us closer to a sustainable future, help decongest the roads. The Bay Area I grew up there has a particular problem with that. But yeah, so carefully collecting all this citywide data can really help out with this problem. So we list some further reading and sources, but yeah, that's our project. So thanks so much for listening.